Hello and welcome back. So we are moving into another interesting part of this series where we look at image generation through Stable Diffusion. So Stable Diffusion is a different foundation model than the LLMs that we have been dealing with. It is essentially meant to generate images after accepting a prompt. So this section has two different topics. One is how do we deploy and run Stable Diffusion as a model on Vultr GPU stack? And then how do we expose this as an API that we can consume within a Jupyter notebook? Let's take a closer look at the first part where we will deploy and run the Stable Diffusion model through a web UI. All right, so let's look at how we can get Stable Diffusion up and running on Vultr GPU stack. So it's a good idea to create a demo user within Vultr GPU stack instead of using the root. So then we'll add the user called demo to the sudoers, and then we'll switch the user to demo. After that, we're going to run apt-get update followed by installing a few libraries that are prerequisites for Stable Diffusion. And then all we need to do is to fetch this script called webui.sh and then simply run that. Everything else is taken care by the shell script, which is webui.sh. Then we open the firewall port on 7860 where the UX for Stable Diffusion listens, and then we simply launch the script. So let's get started. But before that, I want to give you a quick intro to this repo called Automatic 1111 Stable Diffusion Web UI. This is a pretty powerful open source project that adds a useful, user-friendly skin to Stable Diffusion. It has about 22.1K forks explaining us that this is a very popular project and there are a lot of folks. It also has 100K plus stars, which is pretty cool. So this is one of the very popular projects around Stable Diffusion ecosystem, and we're going to leverage this to play with the model. So you can read all the steps involved in deploying this, but this script alone, which is available in the repo mentioned in the description, has all these steps. You just need to run this and you can get started. All right, so let's get to the shell, the command line prompt where we access the GPU stack and get started with the steps. So to save time, I have already created the demo user and ran the initial apt install commands to get all the prerequisites in place. So simply switch the user to demo. And here, if you actually see, I have created a directory called SD for Stable Diffusion. And then I got webui.sh, which I fetched through the wget command. And then we basically make sure we can execute this. And then the port for 7860 should be open. It's already done. And when you run the webui.sh for the first time, it's going to download the entire model. Now, I have already gone ahead and run this. So it's going to quickly launch the UI. But when you are running this for the first time, be prepared. It's going to take at least 10 minutes to get all the model artifacts locally. So let's go ahead and run this. Now this is going to become available on port 7860. So let's wait for the UI to show up. So this is listening on all IP addresses, including the public IP address of this instance on port 7860. This is one of the reasons why we enabled the firewall port for this. All right, so now here is the web UI. Let me quickly run a prompt. So a cute white cat sitting next to the computer keyboard. So when I generate this, it comes back with an image. Every time you hit generate, it comes back with a new image. This is not bad at all. Let's check out another prompt. Taj Mahal during sunset, photorealistic, high quality. So this is going to, again, yeah, this is not bad at all. It's pretty close. So as you can see, this is how you run Stable Diffusion on a GPU stack instance, Vultr GPU stack instance running in the cloud. So in the next tutorial, we will see how we can wrap Stable Diffusion inside a REST API and access that from a Jupyter Notebook. Stay tuned. Welcome back. So far, we have been dealing with Hugging Face TGI, or the Text Gen Inference Server, for serving the LLMs. But when it comes to diffusion models and non-LLMs, Text Gen Inference is not the best choice. So I want to introduce another model serving tool called BentoML. So BentoML is very similar to Hugging Face TGI, but this is more optimized for running containerized workloads, and also a variety of foundation models, including diffusers, which the Stable Diffusion model is based on. So it lets us pull the model and then wrap that inside our own API and expose that. So it is pretty straightforward. You can get the models and then you can create the API endpoint and you can simply run it. So these are the 3 steps. So that's exactly what I have here. It all starts with the pip install BentoML diffusers, transformers, and accelerate. Now these are the dependencies that BentoML would need. I also included them in requirements.txt, so you can use pip install -r requirements.txt to get all of them in place. And then we'll create a directory, and within that, we'll first create what is called as the fetch_sd.py. So fetch_sd will pull the image. So this is equivalent to pulling the image, for example, in Docker. This will basically pull the image from Hugging Face. Again, we are using Hugging Face, but we are not using TGI. So we'll fetch the model, and BentoML will store it locally inside its own catalog. And once that is done, we can look at the available models. And after that, we will open up the firewall port on 3000, and then we simply serve. But how do we turn this model into a service endpoint? Well, for that, we need to do 2 things, or actually 3 things. There are 3 steps. First step is you have to define something called as the pedantic arguments definition. So here, you define certain configuration that will act as the parameters for the actual service. This is basically decoupling the configuration from the actual implementation. So this will give us a chance to add more parameters without really touching the service. So once we define the sdargs.py, we use the service.py file, where we are importing the sdargs. That means we are basically associating this service endpoint with the arguments that we have defined here. For example, the negative prompt, the prompt height, width, optional parameters, and the default values and all of that without actually defining that in the service. So this is a nice way to decouple your API configuration on the parameters from the actual service implementation. So we define that, and then we actually refer to the SD 2.1 that we have fetched earlier. It's the same model. We refer to that, and then we give it a name, and then we simply launch the service. And then we are exposing what is called text to IMG. It takes the input data, and it runs the SD21 runner, which is responsible for actually generating the image. We grab the first image and then return it. So these are the steps involved in exposing a foundation model, in our case the Stable Diffusion model, as API. Define your API arguments in the pedantic sdargs.py file and then associate that with your actual service. So once you have these two files in place, you can simply go ahead and say BentoML serve and service followed by SVC. So what this basically means is it actually looks up this file called service.py, and then we have decorated this method with SVC, so which is going to be the entry point for this API. So we are now letting BentoML pick up the service.py, expose the function or the entry point called SVC, and make it available for REST consumers on port 3000. So let's go ahead and run this. So first step is this. So let's go ahead and run this command. Now what this does is it's going to take a while. If you're running it for the first time, this might take about 10 minutes. So be patient, because what this step basically does is it actually fetches the entire model into this directory, the BentoML directory. So within this, if you go to models directory, you will see SD21 or 2.1, which is the version of the Stable Diffusion that we mentioned in our fetch model file. So once this is done, the next step is to check if it is available locally. So we'll run BentoML models list, and here it is, the Stable Diffusion 2.1, and the size is 33.85. This is pretty large. So that's the reason why when you fetched it, it takes a while. So be patient when you are running the very first Python script to fetch the model. But once it is done, the next step is to allow the firewall, which I've already done, and finally run this command, which is BentoML serve. So this will work without any changes, because I have already created the sdargs.py, and I've also created the service.py file with everything that BentoML needs to expose Stable Diffusion 2.1 as a RESTful service. So let's go ahead and run this. This is going to load the model, and then based on the definition that is coded in service.py, it will expose. So it is now loading all the pipeline components, and in about a minute or so, we should be able to access the API. So that's it. So now let's switch to the browser, and here I have a very simple code snippet running inside Jupyter Notebook. So what we'll do is we'll basically import the request library because we are making a REST call, and then we are hitting text to img. Now what is text to img? Well, if you remember in service.py, this is what we have defined and associated that with service.api. So that is how the REST endpoint will know how to route, what to route. So that is the URL, and the header obviously is application JSON, and then this is the prompt, and the prompt has a black cat with the height and width. And by the way, where is this coming from? Well, we defined that in sdargs. So prompt, height and width. A negative prompt is optional, so we can conveniently ignore that. And then we will simply hit the endpoint. We have everything needed to invoke this endpoint. So this is going to take a few seconds. And if you look at the terminal, it actually shows it is running the execution. Basically it is generating the image. And now it's time to print the image. Okay, that's the programmatic way of accessing Stable Diffusion from a Jupyter notebook. If you want to change the parameters and if you want to make this more production grade, you can go back to the parameters and you can add more parameters, and you can basically control the image generation, like the optimizers and the height and width. And there are at least a dozen parameters that you can associate this service with. And those parameters will increase the accuracy and the quality and the precision of your final output. So this was a quick walkthrough of using BentoML with Stable Diffusion and exposing the Stable Diffusion image generation model as a REST endpoint. All right, hope you found this useful. I'll see you in the next video where we will switch to an audio foundation model. Stay tuned.